Welcome friends, 10th standard math part 2nd and lesson number 2 is Pythagoras theorem. Today we are going to study the application of Pythagoras theorem, Apollonius theorem and practice set 2.2. This Pythagoras theorem can be applied for acute angled triangle and obtuse angled triangle. In acute angled triangle, we can find the relation of a side which is opposite to acute angle and other sides of a triangle. Similarly, in obtuse angled triangle, we can also find the relation of a side which is opposite to obtuse angle and remaining sides of a triangle. Now let's see how Pythagoras theorem is applied for acute angled triangle. This triangle ABC is acute angled triangle in which angle C is acute angle, and let the side opposite to vertex B is denoted by small b, side opposite to vertex C is denoted by small c, side opposite to vertex A is denoted by small a, and let DC is equal to x and BD is equal to, then it will be a minus x. Here we have to prove that AB square, that is side opposite to the acute angle, is equal to BC square plus AC square, that is sum of squares of remaining two sides of a triangle, minus 2 into BC, BC is a side on which perpendicular is drawn, into DC, DC is the distance of the vertex C from the foot of perpendicular D. So we have to prove that AB square is equal to BC square plus AC square minus 2BC into DC. Here two right angled triangles, triangle ADB and another triangle is triangle ADC. These are right angled triangle. Now consider right angled triangle ADB. In this triangle C is the hypotenuse and P and A minus x are perpendicular sides. So by applying the Pythagoras theorem, C square is equal to A minus x bracket square plus B square. Now we consider another right angled triangle ADC. In this triangle B is a hypotenuse and P and X are the perpendicular sides. Therefore we have B square is equal to P square plus X square. From this equation find the value of a P square. P square is equal to B square minus X square. Put the value of a P square from equation 2 in equation 1. Therefore it will be C square is equal to A square minus 2AX plus X square, and value of P square is B square minus X square. A minus X square and plus X square will get cancelled. Therefore C square is equal to A square plus B square minus twice AX. A square is, what is A? BC square. So BC square, B square AC square minus 2 into BC into X is a DC and C is a AB. So AB square is equal to BC square plus AC square minus 2BC into DC. This is the relation by using Pythagoras theorem. How to remember this? Suppose if this is acute angle, then take square of side opposite to that angle, that is AB square. Then take square of sum of other two sides, that is BC square plus AC square. Then take minus sign for acute angled triangle and plus sign for obtuse angled triangle. Then 2 into BC, the side on which perpendicular is drawn, into DC. DC is a distance of a acute angle, that is angle C from the foot of perpendicular D. In this way we can remember this application. Now obtuse angled triangle. Here triangle ACB is obtuse angled triangle in which angle C is obtuse angle, and we have to prove that AB square is equal to BC square plus AC square plus twice BC into DC. What is difference here? Here is the minus sign and here is the plus sign, that only difference. And AD is a perpendicular to BC. AD is perpendicular to BC. Now AD is equal to P, then AB is equal to C, side opposite to vertex C, and AC is equal to B, side opposite to vertex B, and BC is equal to A, side opposite to vertex A. Now here also there are two right angled triangles, triangle ADB and triangle ADC. In triangle ADB, C is hypotenuse and AD and DB are the perpendicular side. So hypotenuse square C square is equal to, what is DB? DB is equal to x plus a. So x plus a bracket square, that is a plus x bracket square, plus other perpendicular side is the p square. Now expand this bracket, a square plus twice ax plus x square plus p square. This is equation number 1. Now consider another triangle, triangle ADC. In this triangle B is a hypotenuse and perpendicular sides are P and X. From this B square is equal to P square plus X square. Find the value of P square. P square is equal to B square minus X square. Put this value of P square from equation 2 in equation 1. Therefore equation 1 becomes C square is equal to A square plus twice AX plus X square plus B square minus X square, plus X square and minus X square will get cancelled. So what will remain is a C square is equal to A square plus B square plus twice AX, that is the AB square is equal to BC square plus AC square plus twice BC into CD. Now how to remember this theorem? At first C obtuse angle, C is obtuse angle. Side opposite to that angle is AB. So take AB square is equal to sum of squares of remaining two sides. Remaining two sides are BC and AC. So their square sum is BC square plus AC square. Take plus sign for obtuse angle. So plus 2 into BC. 2 into BC. BC is a side on which perpendicular is drawn. So we take that side on which perpendicular is drawn, that is 2 into BC into CD. So distance of a foot of perpendicular from the obtuse angle C, that is vertex C. So that distance is a CD into CD. So AB square is equal to BC square plus AC square plus 2BC into CD. Thus we can apply Pythagoras theorem for these two types of triangles. Now next theorem is Apollonius theorem. This is a triangle ABC in which M is midpoint of side BC, and we have to prove that AB square plus AC square is equal to 2AM square plus 2 into BM square. Now here are two triangles, triangle AMB. In this triangle, angle AMB is obtuse angle, and another triangle we take triangle AMC. In this triangle, angle AMC is acute angled angle. Now consider triangle AMB. In this triangle, angle AMB is obtuse angle and AD perpendicular to segment BC. segment AD perpendicular to segment BC. This is construction. Now apply the application of Pythagoras theorem for this triangle. Side opposite to this angle is AB. Therefore we take AB square is equal to sum of squares of remaining two sides, that is AM square plus BM square, AM square plus BM square plus 2 into BM into MD. So AB square is equal to AM square plus BM square plus 2BM into MD. This is the application of Pythagoras theorem, and this is equation number 1. Now consider the another triangle, triangle AMC. In this triangle, angle AMC is acute angle and segment AD perpendicular to segment BC. Therefore apply Pythagoras application of Pythagoras theorem for this triangle. Side opposite to this angle is AC. Therefore we take AC square is equal to sum of squares of other two sides, that is AM square plus MC square, AM square plus MC square. So AC square is equal to AM square plus MC square. For acute angle, angle triangle, we take minus sign. So minus 2 into MC, 2 into MC into MD, into MD. This is application of Pythagoras theorem. But we have given BM is equal to MC. Therefore put MC is equal to BM, MC square, here put BM square, and here also MC is equal to BM. Therefore our equation will be AC square is equal to AM square plus BM square minus 2BM into MD. This is equation number 2. Now add equations 1 and 2. AB square plus AC square is equal to AM square plus BM square plus 2BM into MD plus AM square plus BM square minus 2BM into MD plus 2BM into MD and minus 2BM into MD will get cancelled. So we get AB square plus AC square is equal to 2AM square plus 2BM square. This is called Apollonius theorem. Now let us see how to remember this theorem. In triangle ABC, M is a midpoint of side BC. Then how Apollonius theorem can be applied? That is AB square plus AC square, square of sum of sides on which the median is not drawn, that is AB square plus AC square is equal to 2 into AM square, 2 into median square plus 2 into BM square, that is a 2 into half of square of half of the side on which median is drawn, that is a 2BM square. We can take 2MC square also. So AB square plus AC square is equal to 2AM square plus 2BM square is called as a Apollonius theorem. Practice set 2.2. Question number 1. In triangle PQR, point S is midpoint of side QR, and PQ is equal to 11, PR is equal to 17, PS is equal to 13, and we have to find QR. Now in this triangle, S is the midpoint of side QR. Therefore we can apply Apollonius theorem for this triangle, and that theorem is PQ square plus PR square is equal to 2 into PS square plus 2 into QS square. then we can find QS, and as S is the midpoint of QR, QR is equal to 2 into QS. In this way we can find QR here. Now let's solve. In triangle PQR, point S is midpoint of side QR. It is given. Now apply Apollonius Theorem. Therefore PQ square plus PR square is equal to 2 into PS square plus 2 into QS square. This is according to the Apollonius Theorem. Now put the values. PQ is 11 square plus PR is 17 square is equal to 2 into PS is 13 square plus 2 into QS square. Therefore 11 square is 121, 17 square is 289 is equal to 2 into 13 square is 169 plus 2 into QS square. Now 289 plus 121, 9 plus 1 10, 8 plus 3 11, this will be 410. Therefore 410 is equal to 169 into 2. 9 into 2 is 18. 2 into 6 12. 12 plus 1 13. This will be 338 plus 2 into QS square. Therefore 2 into QS square is equal to 410 minus 338. 410 minus 338. 2 7 plus 4 11, that is 72. Therefore 2 into QS square is equal to 72. Therefore QS square is equal to 72 upon 2 is equal to 36. Therefore QS is equal to 6 units. QS is equal to 6 units. Now we have to find QR. Therefore QR is equal to 2 into QS. Reason is S is a midpoint of QR. Therefore QR is equal to 2 into 6. Therefore QR is equal to 12 units. QR is equal to 12 units. Now example number 2. In triangle ABC, AB is equal to 10, AC is equal to 7, BC is equal to 9. Find the length of median drawn from point C to side AB. That is, we have to find the length of median CD. So we write, in triangle ABC, D is midpoint of side AB. Therefore we can apply Apollonius theorem for this triangle. This is given. So according to Apollonius theorem, AC square plus BC square is equal to 2 into median square, 2 into CD square plus 2 into AD square. And reason is Apollonius theorem. Put the values. AC is 7 square plus BC 9 square is equal to 2 into CD. We have to find out CD square plus 2 into AD square. Now 2 into AD will be 2 into 5 square. And here reason, AD is equal to a half into AB. AD is equal to half into AB. Therefore 7 square is a 49 plus 9 square is 81 is equal to 2 into CD square plus 2 into 5 square is a 25. Now 81 plus 49, 9 plus 1 10, 8 plus 5 is a 13, 130 is equal to 2 CD square plus 2 into 25 is a 50. Therefore 2 into CD square is equal to 130 minus 50. Therefore 2 into CD square is equal to 80. Therefore CD square is equal to 80 upon 2. Therefore CD square is equal to 40. And this 40 can be written as 4 into 10. Therefore CD is equal to square root of 4 is a 2 and 2 root 10 units. So length of median is equal to, therefore length of median is equal to 2 into square root of 10 units. Question number 3. In the figure, segment PS is a median. Segment PS is median of triangle PQR and PT perpendicular QR. PT perpendicular QR. Then prove that number 1, PR square is equal to PS square plus QR into ST plus QR upon 2 bracket square. And number 2 is a PQ square is equal to PS square minus QR into ST plus QR upon 2 bracket square. Now in triangle PQR, PS is a median. Therefore S is a midpoint of QR. Therefore QS is equal to half of QR and SR is equal to half of QR. So we can write at first, in triangle PQR, segment PS is median. Therefore QS is equal to SR is equal to half into QR. Reason is S is midpoint of QR and this is a given. This is equation number 1. Now consider a triangle PSR. In this triangle, angle PSR is obtuse angle and we can apply the application of Pythagoras theorem for this triangle. So write, in triangle PSR, angle PSR is obtuse angle and segment PT perpendicular segment QR, it is given. Therefore segment PT perpendicular segment SR, reason is Q dash S dash R. Now side opposite to this angle is PR. So PR square is equal to sum of squares of remaining two sides, PS square plus SR square plus 2 into SR into ST. Reason is application of Pythagoras theorem. Therefore PR square is equal to PS square plus SR. SR is equal to half into QR. That is QR upon 2 bracket square plus 2 into SR is QR upon 2 into ST. From equation 1. Therefore PR square is equal to PS square plus this 2 will get cancelled, QR into ST plus QR upon 2 bracket square. This is the first proof. Now consider triangle PSQ. In triangle PSQ, segment PS. In triangle PSQ, angle PSQ is acute angle and PT perpendicular QS. PT perpendicular QS. So apply application of Pythagoras theorem for this triangle. This is a acute angled triangle. So side opposite to this angle is a PQ. Therefore PQ square is equal to remaining two side square PS square plus QS square. PS square plus QS square minus 2 into QS into ST. This is application of Pythagoras theorem. Application of Pythagoras theorem. Therefore PQ square is equal to PS square plus QS is equal to half into QR. That is QR upon 2. QR upon 2 bracket square minus 2 into QS is QR upon 2 into ST. This is from equation 1. Therefore, PQ square is equal to PS square. This 2 will get cancelled, minus QR into ST. Minus QR into ST plus QR upon 2 bracket square is proved. Question number 4. In triangle ABC, M is midpoint of side BC. AB square plus AC square is equal to 290 centimeter square. AM is equal to 8 centimeter. Find BC. So we can apply Apollonius theorem for this triangle. So we can write, in triangle ABC, point M is the midpoint of side BC. This is given. Therefore, BC is equal to 2 into BM. Equation number 1. Also, we have given AB square plus AC square is equal to 290 centimeter square. This is given. Now, in triangle ABC, apply Apollonius theorem. AB square plus AC square. AB square plus AC square is equal to 2 into AM square plus 2 into BM square. Apollonius theorem. Now AB square plus AC square is 290 is equal to 2 into AM square, that is 8 square, plus 2 into BM square. Divide both sides by 2. Therefore 145 is equal to 8 square is a 64 plus BM square. Reason is dividing both sides by 2. Therefore BM square is equal to 145 minus 64. Therefore BM square is equal to 81. Therefore BM is equal to 9. Taking square root on both sides. Taking square root on both sides. BM is equal to 9 here. We have to find BC. BC is equal to 2 into BM. This is from equation 1. Therefore BC is equal to 2 into 9. Therefore BC is equal to 18 centimeter. We have BC is equal to 18 centimeter. Example number 5. In the figure, point T is in the interior of rectangle PQRS. Prove that TS square plus TQ square is equal to TP square plus TR square. Here PQRS is a rectangle and construction is draw segment AB parallel to side SR. Segment AB parallel to side SR. This is construction. And the side PQ parallel to side SR. The sides of rectangle are parallel to each other. Therefore, side PQ is parallel to segment AB parallel to side SR. Therefore, these three are rectangles. PQRS is a rectangle. Then ASRB is also rectangle, and APQB is also rectangle. These three quadrilaterals are rectangle. Now AP is equal to BQ, opposite sides of rectangle. AS is equal to BR, opposite sides of rectangle, and these angles are 90 degree. That is angle PAT and angle TAS are 90 degree. Therefore, here also angle angle QBT and angle TBR, these two angles are also 90 degree. Therefore, there are four triangles are formed, 1, 2, 3 and 4. These all four triangles are right angled triangle. Now consider a triangle TAS. In right angled triangle TAS, TS is a hypotenuse. Therefore, TS square is equal to AT square plus AS square. TS square is equal to AT square plus AS square. This is equation number 2. And in right angled triangle TBQ, in this triangle TQ square is equal to TB square plus BQ square. TQ square is equal to TB square plus BQ square. This is equation number 3. Now add equations 2 and 3. If we add equations 2 and 3, we get TS square plus TQ square is equal to AT square plus AS square plus TB square plus BQ square. Now AS is equal to BR. AS is equal to BR and BQ is equal to AP. AP is equal to BQ. Therefore, BQ is equal to AP. Therefore, that equation becomes TS square plus TQ square is equal to AT square plus BR square plus TB square plus AP square. So, TS square plus TQ square is equal to, rearranging the terms, AT square plus AP square plus TB square plus BR square. This is equation number 4. Now consider the triangle PAT. This is right angled triangle. Therefore, applying Pythagoras theorem, TP square is equal to AT square plus AP square. TP square is equal to AT square plus AP square. Pythagoras theorem. This is equation number 5. And in right angled triangle TBR. Now consider this triangle. In this triangle, TR is a hypotenuse. Therefore, it will be TR square is equal to TB square plus BR square. TB square plus BR square according to Pythagoras theorem. This is equation number 6. Now add equations 5 and 6. So we get TP square plus TR square is equal to AT square plus AP square plus TB square plus BR square. Now see equation 4 and equation 7. For equation 4 and equation 7, its right sides are equal. Therefore, left sides will be equal. Therefore, TS square plus TQ square is equal to TP square plus TR square. This is proved.